Transforming lead into gold, an ancient alchemical quest that has remained the stuff of legend for millennia. That is, until today. Alchemists and philosophers have built their legacies on the belief that it was possible. Now, particle physics has finally cracked the code, a discovery thousands of years in the making. One where ancient mysticism crosses over with nuclear physics. One of the world's most famous laboratories has achieved the impossible, and they did it by accident, transmuting lead into gold. How did they do it? What's the real science and secret of the mythical Philosopher's Stone? And how does it tie in to ancient writings about the origins of all matter and the universe itself? Join me as we unravel all this and much more and enter the Codex Legendarium. I'm Shelby Melanson. The quest to turn lead into gold comes from alchemy, a study that combined elements of chemistry, philosophy, and even mysticism that dates back several thousand years, all the way to ancient China, Greece, India, Egypt, and the Islamic world. Aristotle wrote that alchemy is rooted in one core idea, that all matter originates from the same physical substance, basically a formless essence of all things, called Prima Materia, or first matter. One that the creator, God, could use to create all varieties of life. But exactly because all things, according to this theory, come from that same core material, the theory was that they could be transmuted, transformed into other matter. Naturally, it didn't take long for the idea to come up that basic material that isn't rare or valuable could be transformed into something that is rare and valuable, like turning base metals, like lead, into noble metals, like gold, which was considered the final perfected form of metal. The idea of artificially turning lead into gold became so coveted that it was named Chrysopoeia, from the Greek chrysos, or gold, added to the word poin, or to make. After all, if nature could turn base substances into gold over time, why couldn't the process simply be sped up by humans? But there's a catch. To do it, alchemists believed that you needed the ultimate form of Prima Materia, a legendary substance you've probably heard of as the Philosopher's Stone. It was mainly described not as a stone, but as a kind of powder or tincture. And turning lead into gold isn't the only thing it was good for. More on that later. Most famously, in part thanks to J.K. Rowling, a Frenchman by the name of Nicolas Flamel was believed to have successfully created the stone. He was born back in the year 1330 and worked as a bookseller and public notary. The rumors about his alchemical prowess didn't begin until long after his death. An alchemical book published in the year 1612 started the speculation. It suggested that Flamel had successfully created the stone after decoding a copy of a sacred religious text, and then replicating its recipe for the stone, and then using it to grant himself and his wife immortality. The legend has been both questioned and defended ever since. Going further back, the world's oldest known alchemy book, the Cheirokmeta, written by alchemist Zosimos of Panopolis in ancient Egypt, is the earliest known mention of the stone and transmuting gold. Around the same time, Cleopatra the Alchemist, not to be confused with the Egyptian queen who lived around 300 or so years earlier, was also credited as one of 4 women who worked on creating the Philosopher's Stone. We need to pause the history lesson for a second here to explore a really critical question to this discussion. How does the science of transmutation actually work? Here's a quick refresher. Both lead and gold are pure substances or elements on the periodic table. They're made up of atoms, along with most other things in the universe, and those atoms are made up of protons and neutrons, which form the nucleus, and electrons, which orbit the nucleus. Now, the number of protons in an atom, known as that element's atomic number, is basically what makes an element that element. It defines what kind of substance it is. Lead has 82 protons, while gold has 79. Yes, that 3-proton difference, 3 unfathomably small particles, are at the core of the entire ancient lead-to-gold saga, and overcoming them is effectively chemically impossible. or so we thought. Side note, elements like gold and lead are both heavy elements because they're metals with high atomic numbers. Elements can also have different variations called ions and isotopes if they have different numbers of neutrons. Keep this in mind, it's going to come up again later. Back to the history. The dream of turning lead into gold persisted for several thousand years, as we've mentioned. But it wasn't until 1902 that science as we know it proved that the age-old belief in transmutation was actually theoretically possible. That year, New Zealand's physicist Ernest Rutherford and English radiochemist Frederick Soddy discovered something unbelievable. Through the process of radioactive decay, some elements naturally transform into other elements. Scientific proof of transmutation. Not through alchemy, but thanks to nuclear radiation. Rutherford continued his studies, and in 1919, he found that he could transform nitrogen into oxygen just by bombarding it with alpha particles via radiation. It's still far from transforming a physical metal, but it was a huge step forward. Next were discoveries from Japanese physicist Hontaro Nagaoka and later a German chemist who bombarded mercury, in other words, a metal that's liquid at room temperature, with particles to create trace amounts of gold. But it wasn't until 1980 that the first modern evidence of transforming a solid metal into gold was born. American nuclear chemist Glenn Seaborg used a particle accelerator to transform bismuth, a heavy, brittle, silvery white metal with 83 protons in its structure, into gold. It was an incredible accomplishment. The dreams of alchemy come to life in a modern scientific controlled setting. But it still wasn't gold. All that effort, all that progress, but still, no philosopher's stone, no transmuting gold. But what if I told you that particle physics finally cracked the ancient mystical code? Full disclosure, we're going to talk about the Large Hadron Collider. That's right, CERN, Geneva, Switzerland, very own particle physics lab. This facility has been at the heart of some very extensive speculation. If you know, you know. But we're talking about turning lead into gold here. So we're not going to talk about the statue of Shiva or the Mandela effect or the alleged black holes or time shifts or strange cloud formations or any of the other theories. That is a conversation for another day. Okay, back to the gold. So how did they do it? Here's the crazy part. It was actually an accident. And it's been happening as an unintended side effect right under their noses of other particle experiments for a while, specifically the ALICE experiment. And nobody noticed! ALICE stands for a Large Ion Collider Experiment. And that's basically what it does. It's one of the Large Hadron Collider's main detectors, and its job is to study the physics of how heavy ions, the nuclei of heavy elements like lead or gold, interact when they're smashed together. They say the goal is to recreate something called the quark-gluon plasma, or QGP. It's a state of matter that they say existed just moments after the Big Bang. In other words, they're trying to learn more about their theory of the moment of creation of the universe by recreating it. You can see where some of the more interesting theories about these experiments come up, but I digress. So, here's how it works. Inside the collider, scientists aim beams of lead ions at each other, specifically lead-208, the heaviest and most abundant lead isotope out there. These particles are traveling so fast that they crash into each other at just a hair under the speed of light. But they notice that once in a while, instead of hitting each other head-on, some of these ions would have near misses and kind of glance past each other. Okay, so what? Well, those particles are traveling so fast and have such strong electromagnetic fields that the side impacts create a pulse of energy called electromagnetic dissociation. It's so strong that the particle, in other words the lead nucleus, actually ejects 3 of its protons and 2 of its neutrons. Remember earlier how we talked about the chemical difference between gold and lead is basically just that lead has 3 more protons than gold? With those 3 sent packing during these collisions, the lead is transformed into gold, specifically gold-203. More on that in a second. Because this wasn't the intended goal of the experiments, it took a while for scientists to actually notice that this was even happening. Once they did, they calculated that between 2015 and 2018, The experiments had created roughly 86 billion gold nuclei, or approximately 29 trillionths of a gram. That's 10 zeros after the decimal point. They also found a different particle accelerator had been transforming lead into gold all the way back between 2002 and 2004 in even smaller amounts. So not exactly enough for, say, the processor in your smartphone, which has roughly 0.034 grams of gold, or your laptop, which has even more at about 0.2 grams, much less, say, a nice piece of gold jewelry. So there you have it. The alchemist's dream of transforming lead into gold is real, and they were right all along. The team behind these particle experiments published the findings in May 2025 last year, but there are a couple of problems. Aside from the extremely small quantities being created, the gold didn't stick around. And I mean really. The trouble with smashing ions of lead together is that the transformation only lasts for a fraction of a second, because the resulting gold ions are unstable, radioactive, and moving super fast. So they usually either break down into other particles or just smash into the collider's machinery. They last literally about 1 microsecond, or 1/1,000,000th of a second. The other thing, it's really, really expensive to do this. From 2009 to 2012 alone, running the Large Hadron Collider cost CERN around 1.1 billion Swiss francs, or around 1.4 billion USD. And that doesn't include the cost to build the collider, which came in at an eye-watering $7.8 billion. Compare that to the cost of gold per gram, which in the US is just over $160 at the time of writing. So that puts the cost to gold ratio at a pretty horrific low for CERN, significantly less than even the experimental methods for extracting minuscule amounts of gold from things like seawater. Probably safe to assume the scientists won't be launching an alchemical side hustle anytime soon, and that coffers, treasure chests, and pots at the end of the rainbow worldwide are still out of luck. Here's the thing. Even going back to the earliest mentions of alchemy and transmuting lead into gold, it was never about getting rich. At its core, alchemy is composed of not only scientific experimentation and chemistry, but also philosophy and spirituality. Alchemists believed that all matter in the world could be perfected, purified, by going through stages of cleansing. But it didn't just extend to matter. Remember Prima Materia? The idea that everything, really everything, comes from one original source? If that's true, doesn't that also apply to us? In the same way alchemists wanted to transform common metals into their highest, most refined forms, the hunt for the ultimate alchemical tool represented the search for transforming ourselves. Physically by way of Philosopher's Stone immortality, but spiritually as well. Throughout the ages, turning lead into gold has served as a metaphor for the purification of the soul just as much as any metal. It's the idea of raising something up from the mundane into something that's seen as divine. Spiritual practitioners and religious believers through the ages have called it the search for enlightenment. Today, we might call it personal growth, or reaching higher levels of our consciousness. Ultimately, we won't be pumping out gold bars from lead anytime soon. But if there's one lesson to take away from this discovery, maybe it's that history reminds us that what was once thought impossible, the stuff of legends, might not always stay that way. What do you think? Is turning lead into gold our biggest feat yet for proving ancient beliefs true in the modern era? Do you think we'll ever see it happen on a larger scale? And what do you think the ancient alchemists would say if they could see their life's work realized? I would love to hear your thoughts about this in the comments. And if you have an idea for something you'd like to see a future episode on, let me know. I've been reading a lot of great emails and comments from all of you lately. And of course, if you enjoyed this deep dive into mysteries, myths, culture, and science, please take a second to like and share this video. And if you want to see more, subscribe. It really, really helps us get the word out. Until next time, stay curious. Thank you.